All right. So today, what we're going to do is we're going to go over a little bit about what we talked about yesterday with lightning. And I had a video up that showed some pictures and stuff, but it got hit for copyright. So I won't be able to post that. But I wanted to go over with I know you guys love my drawing. So I'm going to try to draw some clouds here. And I want to talk about what actually happens inside of a cloud when you have this thunder and lightning. Okay. And essentially, what the book is trying to tell us is that there are negatively charged particles. If you go back in your science book, these are going to be negatively charged particles at the bottom of the cloud. And on the bottom near the Earth, there are positively charged particles. Okay. Now, if you know anything about the way a battery works, okay, when you, like, for example, when you look at a battery, let's say a AA battery, I know you guys have seen these before. Okay. And you got a little nub on top here, and you put these in, say a AA. Okay. Awesome drawing, right? The negative part of the battery and the positive part of the battery work pretty much the same way, right? There are, and we've talked about this before, there are within an atom, there are protons, electrons, and neutrons. Okay. When you send free electrons through a material that's conductive, right, the electrons can travel from atom to atom and move across the surface and be delivered to another place. So when you have a wire and you have a battery on one end, right, and you have a ground on the other, okay, the electrons can flow through and hit your ground, right? That's how electricity moves. So with this cloud, right, since there's this positive and negative charge, there's a natural tendency for these two to interact with each other, right? And so as the cloud moves along and you have this negative charge and this positive charge, the electrons down here want to move, right? They want to move to fill the spaces, right? And so what ends up happening, according to the book, is that eventually this attraction becomes so strong that it causes lightning bolts, right? And remember what they said was that the first thing that happens in most cases is that a stepped leader starts to, and it's a really jerky pattern. If you can't see this, it happens so fast that you can't see it. Okay, so this is right before, within a fraction of a second, this stepped leader starts to jerkily go down, right? And from the ground comes what's called a return stroke. Okay. Which is let's see if I can make this happen here, which is the response, and it's that lightning strike, right? It's what you see. It's that return stroke that follows the stepped leader. The stepped leader comes first, and the return stroke is what happens as the stepped leader gets closer to the ground. The return stroke completes the circuit essentially and fires off this big lightning bolt, right? Which is what you see. Now, remember, we also said that within this, there can be multiple lightning strikes because you can have multiple return strokes, right? And so that's when sometimes you get that flickering when you see the lightning. So this is essentially how this works. And I know I said a whole lot. If you don't understand what I'm talking about, then you can ask some questions. But essentially what you really need to know is that with lightning bolts, there is this stepped leader, which is that sort of feeler electricity that comes out of the cloud and starts to move towards the ground. And as it gets closer and closer to the ground, the return stroke occurs, which causes that big bright burst of light that you see in lightning. And so what we're going to do is we're going to continue our reading, and we are going to go to page 250, and we're going to start talking about tornadoes. 250, the tornado. A severe thunderstorm sometimes produces a terrifying phenomenon called a tornado. A tornado is a narrow funnel of powerful, rapidly whirling wind that stretches from a cloud to the ground. There are an average of 1,200 tornadoes in the United States each year. Common names for tornadoes include twisters and cyclones. To a meteorologist, a term cyclone refers to any low-pressure system in which winds rotate in the direction that would be caused by the Coriolis effect, counterclockwise in the northern hemisphere. The rotation may or may not be caused by the Coriolis effect. All tornadoes are rotating low-pressure systems, and most are cyclones, i.e., most northern hemisphere tornadoes rotate counterclockwise. However, about 5% of tornadoes rotate backward, clockwise, in the northern hemisphere and are not true cyclones. There are also many other types of cyclones that are not tornadoes. So remember what I said about the low pressure areas are the ones where the wind or the air is moving upward, right? It's moving up into the clouds, and that's a low pressure area. It creates that low pressure. It feeds storms, right? Tornadoes may be different shapes and colors. The best known shape is a funnel with the point toward the ground. However, they can also look like narrow ropes stretching from the cloud to the ground, or like giant swirling pillars, wider than they are tall. When a tornado has just formed, it is often white or gray, like a cloud. Because of condensed water vapor, however, it will darken and possibly turn different colors as it picks up debris. Sometimes tornadoes in dry areas are clear. Such a tornado can be seen only by the swirling mass of debris that forms around its bottom end, right? So there's different types of tornadoes. They're going to look different. You can see a picture of some different tornado shapes in your book on page 250. So let's talk about tornado formation. Scientists believe that tornadoes form in two different ways. The first mechanism, which forms small tornadoes, involves interactions between a thunderstorm's downdraft and an updraft, forming a cumulus cloud in front of the downdraft. Because these small, short-lived tornadoes are difficult to study, the mechanism is not well understood. This method is believed to be responsible for the formation of tornadoes in single-cell and multiple-cell thunderstorms, although it sometimes forms tornadoes in supercells as well. So there's a lot of this that we don't understand, right? But what they're saying there is that one of the mechanisms appears to be an interaction between the downdraft and updrafts. Now, the downdraft, remember, is the wind that's being caused by the release of rain inside of a cloud, which combats against the updraft. The updraft is from that low pressure area. The air is rising. It's causing this updraft. It feeds warm air and moist air to the cloud, which causes it to grow. And so they're saying that this relationship or some sort of a reaction between the downdraft and the updraft creates this tornado. The most powerful tornadoes are believed to form from the rotating updrafts found in many supercell thunderstorms. Such a rotating updraft, or mesocyclone, begins when differences in wind direction and speed at different altitudes cause a horizontal cylinder of air to rotate. An updraft picks the rotating cylinder up, causing the cylinder and updraft to merge. This slowly rotating column of air, initially about 10 to 19 kilometers, 6 to 12 miles in diameter, is the mesocyclone. The mesocyclone will become the heart of the supercell, right? So these supercells are sort of extremely strong thunderstorms, right? And so they're saying that this cyclone effect is what also feeds these, or is the heart of these supercells. They're actually cyclones. You can see this sort of idea in hurricanes, right? There's this rotating effect in a hurricane. There's this updraft. The Coriolis effect is causing these cyclones to form. We looked at that when we studied the Coriolis effect. Remember that instead of the air just going up straight up, it actually forms a cyclone because of the spin and rotation of the Earth, right? As the supercell grows, the mesocyclone draws air up through itself like a pipe. The mesocyclone tightens and stretches, shrinking in diameter while growing vertically and increasing in wind speed. It often stretches the entire height of the supercell cloud. The first visible sign that a tornado may be forming from a mesocyclone is the formation of a wall cloud, a large rotating cylindrical extension from the base of the supercell. Sometimes precipitation will obscure the view of the wall cloud. Even once a wall cloud forms, only a handful of supercells will go on to produce tornadoes. However, the surface winds beneath a wall cloud may be 120 kilometers an hour, 75 miles an hour, even if a tornado never forms. So even if you don't see this tornado, it still can become extremely dangerous, right? Within the mesocyclone, a smaller cylinder of rotating air may form. As in the mesocyclone, the air in this cylinder spirals upward. This inner cylinder grows toward the ground, just as the mesocyclone did, getting longer and thinner with more rapidly rotating winds. When this inner region of rotating air reaches the ground, it becomes a tornado. The pressure inside a tornado is much lower than the pressure around it. Because of this, air pulled upward by the tornado cools adiabatically, much faster than air around the tornado does. If this air reaches the dew point, it condenses into a rapidly swirling condensation funnel, the most distinctive visual feature of a tornado. Sometimes a condensation funnel may reach only partway to the ground, or may not form at all. However, the tornado still stretches all the way from the thunderstorm cloud to the ground. Right. So remember, it said that some of these tornadoes aren't even visible except for the debris that they're picking up. So not all of them have that sort of cloud-looking appearance. Only some of them do, right? And so they're saying that that is caused by condensation, and they call that a condensation funnel. Tornado occurrences. There is no real season for tornadoes. They occur at different times and during different months, depending on location. Generally, in the southern United States, tornadoes occur between March and May. In the northern United States, they occur in the late spring through early summer. Tornadoes occur all over the world, but no place on Earth is better suited for their formation than the Mississippi Valley and eastern Great Plains of the United States, nicknamed Tornado Alley. In this area, warm, moist air moves northward from the Gulf of Mexico as cooler, drier air moves eastward from the Rocky Mountains. These two air masses collide, and the dry air forces the moist air skyward. It ascends. As it ascends, the moist air cools below its dew point, allowing water vapor to condense. This process releases energy that fuels the formation of supercells. On April 27, 2011, such weather conditions created 218 tornadoes in less than 24 hours. So that's pretty crazy. So let's understand a few things. When we talk about updrafts and downdrafts, right? When we talk about the formation of supercells and what we know about them, you got to remember when you are looking at the Weather Channel and they say that there's a low pressure area, and usually they'll have these little they'll try to show you which direction this low pressure area is forming. In this area, the air is moving upwards, creating a low pressure area. These low pressures, since the air is moving upwards, it's going to feed these clouds, right? So imagine at the same time, there's a downdraft, right? What they're saying, and I know that this drawing is absolutely horrible. Let's try this again. I know I am not going to win any awards for my artist skills. Okay. So you have your updraft. And then down here, you'll have this downdraft, right? What they're saying is that this relationship between this updraft and this downdraft will cause supercells to form, will cause tornadoes, and they're not exactly sure what mechanisms start these tornadoes, but they are pretty sure that it is this relationship between the updrafts, which cause the low pressure areas, and the downdrafts, which cause the high pressure areas, right? So what I want you guys to do today, there's a lot to read. I want you to read over this section. I really want you to understand it. There's a lot of material to go over. But what I want you to do is I want you to what I want you to do is I want you to write me a paragraph of at least 10 sentences. And I want you to explain to me what a tornado is and how they think that they form. One paragraph, 10 sentences, make it cohesive. What is a tornado? How do they form? How do they believe that they form? Give me some examples. And then I want you to draw me a picture of one type of tornado. Right? Draw me a picture of one type of tornado. Right? And that'll be your science lesson for today.